Okay, so hi everyone. Welcome to the second de.NBI Cloud user meeting. My name is Peter Bellmann. I'm from Bielefeld University. I'm working at the de.NBI administration office, and my main task or my job there is, well, I'm reading the project applications. So if you ever applied for a de.NBI Cloud project, I guess I reviewed it already. And my other task is to build or develop in collaboration with my de.NBI Cloud colleagues an environment for all kinds of life science research projects. So the objectives of this meeting are, well, if you are new to the de.NBI Cloud concept, you have the chance to hear today about existing de.NBI Cloud projects. So you will hear how they are using the cloud with their services or pipelines. The main focus will be best practices. And we also have a few maybe advanced topics, like how can you scale with your pipeline or service in the cloud, or how can you operate your service in the cloud. And last but not least, it is really important for us that we can learn also from your use cases, right? So that we can maybe improve our service or maybe expand our existing service portfolio. But before I talk more about cloud computing and de.NBI Cloud, let me first say a few words regarding the organization to which the de.NBI Cloud belongs to. So de.NBI is the German network for bioinformatics infrastructure. It is a distributed national infrastructure supported by the Federal Ministry of Education and Research. Since, I think, 2016, it runs also the German Elixir node. So Elixir is like, well, it's quite similar to de.NBI, but it operates more on a European level. So it's like, like an intergovernmental organization that connects different life sciences projects or resources across Europe. And de.NBI consists of three parts. So one part is that we offer bioinformatics services for basic and applied life sciences research. We offer free of charge trainings and workshops in Europe. And we offer with the de.NBI Cloud a free of charge computational resource. So the whole consortia of de.NBI consists of 42 project partners, 32 institutions, and these institutions are organized in what we call service centers. And every service center has a specific focus on a specific research topic. So like human bioinformatics, RNA bioinformatics, plant bioinformatics, cloud computing is also one topic. And as part of de.NBI Cloud started in 2016. So that's when we, started to buy hardware. And I think at the end of 2017, the whole Cloud Federation went in production. It currently consists of 6 cloud sites. Since June, I think, we have a new cloud site in Berlin. And since we are a federation, so we are a cloud federation, it is quite important for us that we are using the same underlying system, what we call infrastructure as a service system. And it's called OpenStack. And at the moment, we offer more than 20,000 cores and 35 petabytes of storage capacity. Since the start, we have a growing number of users and projects. And at the moment, we have about 600 registered users. Most of them are developers and 190 projects. And among those projects, we have, projects like what we call science gateway projects. So these are services like web services that are offered to other researchers. So examples here are Use Galaxy U and Silva NGS and also the Eggnog Mapper. 2 of them will be presented today. And Eggnog Mapper was presented last year at the first de.NBI Cloud user meeting. So As I mentioned before, we offer our service free of charge. Our only requirement is that an application for, well, describing the required resources for de.NBI Cloud project must be submitted by a principal investigator of a German university or research institution. And, well, this application should be submitted through our portal. It will be then reviewed by a scientific committee and also by me. And, well, it will be, after approval, this project will be created in the portal, and the resources will be allocated at one or maybe even multiple cloud sites. So, well, but what is actually cloud computing? Well, most explanations are quite similar to this one I have here on my slide from the Azure cloud developers. It is, well, this is the delivery of servers, storage, networking, software, databases over the internet. So this means, well, you don't have to buy really expensive hardware, really expensive storage or compute components in your organization. You just use it, you access it through or over the internet. This also means that, well, you don't have to know how the hardware down in the cellar of a compute center looks like, or a data center. So this complexity is hidden from you. So in order to simplify the process of, well, requesting the resources that you exactly need for your research. Well, the basic building block of cloud computing is a virtual machine. So maybe some of you have ever used technologies like VirtualBox on your laptop or on your computer. So VirtualBox or a virtual machine is an emulation of an operating system, and VirtualBox allows you to start, as an example, to start on your Linux-based system, a Windows-based operating system, or the other way around, a Windows-based system on a Linux-based system. And when you start such a virtual machine in VirtualBox, as an example, you have to set or specify parameters like how many cores should be available for the system, how much RAM should be available, what kind of operating system should be started. And well, and the same holds for the cloud. So when you will see tomorrow, when you want to start a virtual machine, you also specify these parameters, you click on launch, and the VM will be started. But again, it's hidden from you actually on what kind of hardware, where it is running, how the hardware is interconnected, and so on. So all you will see is that you can connect to this machine, and you can connect to it through different protocols, like as an example here through the secure shell protocol. So again, this will be presented to you in way more detail, of course, at the OpenStack workshop tomorrow. So as I mentioned at the beginning, we are a cloud federation. So we have multiple cloud sites. We also offer multiple services, and we want to offer more services in future. And it was from the beginning quite important to us that you can access this the services that we offer or will offer in future as easy as possible. So that's why we integrated quite early with this technology called Elixir Authentication and Authorization Infrastructure. And this technology allows you to reuse your home institutional account, your Orchid account, your Google account or LinkedIn account to access all these services that we offer now and will offer in future. Which means that you don't have to create a new account, you don't have to create a new password for every cloud site or for every service that we offer. So again, the main focus of this meeting are best practices, and I just want to give you, maybe a teaser for those workshops. And one topic that will be covered tomorrow and on Thursday is infrastructure as code. And let me explain to you what it actually means. So let's imagine you want to start 2 of those virtual machines, and you want to install on every of these virtual machines a specific tool, a bioinformatic tool, whatever. So what you could do is, you will see tomorrow, you can go to your website, you click on, well, start a virtual machine or launch a virtual machine. You configure this VM, you specify these parameters, right? So how many cores, how much RAM, and so on. Then you click on launch. Okay, then you can access to this VM, you can install the tool, and that's it. So and in this case, you will do this twice. You could do this for 3 VMs, maybe 4, maybe 5. It depends how patient you are. But let's imagine you want to start hundreds of VMs, so you will hear that later today that there are services that start hundreds of VMs. You don't want to click 100 times on a website somewhere to launch a VM, right? And there is a solution for this problem. It's called, again, infrastructure as code. There are different tools available that allow you to specify your setup, your infrastructure, and the setup especially of your virtual machine in multiple files. So you say, okay, I need a VM of this size with these kind of tools installed, and then you provide these files to a specific tool, right? And say, just start the VMs for me. And then it will, well, start as many VMs as you specify in these files. And you can do even more. So this is really just a teaser. You can also assign like roles to these VMs. You could say, okay, these 2 VMs should be worker nodes. So if you want to set up a cluster, for example, right? And cluster is just accessible for you, so that just you can use it. And one smaller node should be a master node, so that you can log into the master node and then submit jobs to the other nodes. And these roles you can specify in these files. And again, there will be 2 workshops for this topic. One is the BibiGrid and Ansible workshop on Wednesday, and the other one is a Terraform workshop on Thursday. Another really important topic is containerization. And containerization tries to solve the following problem. Let's imagine you want to install 3 different tools on your virtual machine. Okay, so this might work quite well with 2 tools. One tool depends on the system library called A, and a different tool depends on the system library called B. And this works without a problem. And then you want to install a 3rd tool, but this tool depends maybe on a newer version of system library A, right? So there will be conflict. So you then have to decide, okay, I could maybe run the first tool, the red gear in this case, for example. Then I will remove the system library, install the newer one, install the other bioinformatic tool represented by the blue gear, and then it will work. And again, okay, this might work for 2 or 3 tools, but let's imagine you want to scale up. You want to install maybe whatever, 10, 20, 30 different tools. And a solution to this problem is called containerization. There are technologies that, well, we call they are lightweight virtualizations, and there are communities out there that try to package like bioinformatic tools, in this case the biocontainers community. And in these containers, these system libraries, or the libraries, any library that your tool depends on, is in the same container. So there won't be a conflict if you install tools that depend maybe on different version of a specific library. And this will be presented to you by Björn on Wednesday. Another part are workflows. So workflows try to solve the problem. Well, you have your specific, let's say, a pipeline, or maybe some kind of analysis steps that you want to run automatically. And so how would you specify this? You could write a script, of course, it would be possible, but there are special technologies called workflow engines that allow you to specify the exact input of, or the input of, or the output of one tool as an input of the other tool. And this also helps you to, for example, say, okay, I maybe have a small data set. I want to run it on one virtual machine. And one day you will have a big data set and you want to say, okay, I want maybe to start whatever, 20 virtual machines, and just provide this one definition of this workflow, and it will spin up these jobs for you on the different nodes, and you can process your data set faster. This will be presented on, or one of these technologies called Nextflow will be presented on Wednesday. And the last topic I want to give you a teaser is the management of multiple containers. So the question is, let's say you have your set of containerized applications, and you have maybe a set of nodes, and you want to distribute these containers on these nodes. Then there are technologies that help you to accomplish this quite easily. And one technology that will be presented to you is called Kubernetes. Kubernetes allows you to automate the deployment, scaling, and management of containers. It was initially developed by Google, and I think now Cloud Native Foundation is maintaining Kubernetes. And this technology will be presented. So this technology you can also use in the de.NBI Cloud, and it will be presented to you on Wednesday and on Thursday. So there are really many people involved in this project. There are a lot of de.NBI Cloud admins and developers that will really do a great job in developing a service which is unique in Germany. So this list should not be complete. It's not exhaustive. So thank you for listening. This was my first part, but I have to tell you a few organizational details. So we will have a Birds of a Feather section tomorrow. And as I stated in my mail, I have one agenda document that I will update anytime we have something new, right? For example, like a new room where we go to, or a new document, or whatever. And you will find there a link to a document where you can add your topic that you would like to discuss with us, right? So please add your name and the topic to this list, so that we can collect it and maybe, go to the different rooms that we have here in this building. Another point, today will be the self-paid dinner at around 20 o'clock. The restaurant will be Essighaus. So please, if you haven't done so far, please add it to the agenda document, to the list which is linked in the agenda document. If you like, we can meet at 7:15 in front of the Bioquant building and go together. So you can decide. Well, and today will be the chat with your admin session. So this is your chance to talk to the cloud experts. And I will show this later, the slide later, an updated version from it. So I labeled the admins, so they have like a yellowish label. So you will notice that there are admins in this room, and you can just go to them and talk to them about different problems you might have, right? So that's it. This was my last slide.